Hey folks, welcome to the proof video that I'm creating here, and I apologize that it's a little bit informal. I'm going to create a more formal one later on, but for now, I'm going to go through a couple of the proofs and just some of the material from the more deductive reasoning chapter to make sure you guys have a grasp of and you're prepared for the assessment. So the first thing I want to say is that you've really got to understand validity, what it means to be valid, to understand the proofs, because the proofs are all about deductive knowledge. And validity, remember, is the assumption. If we assume that the premises of an argument are true, then the conclusion follows with certainty. And so if you take page 72, if you go to page 72 of the reader, which is right here, it's the page with all those argument forms. These are all valid arguments, and we could substitute for the variables actual ideas and concepts, and we could see why they're all valid. But symbolic logic is sort of just simplifying things to work with valid argument forms to see what we can prove. And that's why we call these proofs. You're proving that the arguments are valid using other valid argument forms. That's what you're trying to do. So every time you see a proof and you see the conclusion, that's what you want to have in the back of your mind. You're trying to get on the last line of your proof the conclusion so that you've proven that that argument is valid. So let me just go through a couple natural language argument forms first, modus ponens and modus tollens, and show you how that converts into symbolic logic, and then I'll go through a couple of proofs. Because again, if you don't really understand validity, the idea that if we assume the premises are true, the conclusion will be certain, it's kind of hard to understand how the proofs work, because all the proofs is just proving validity. That's it. So you got to understand validity before you really understand the proofs. So let's start with modus ponens. So if I said, if I am hungry, make sure that you guys can see that. Okay, so if I'm hungry, then I will eat. Right? So now I've made a conditional claim saying that if I'm hungry, I will eat. If one thing happens, the other thing will happen. And then the second premise would be, I am in fact hungry. Well, I won't use that symbol yet, because we're not in symbolic logic part yet. And the conclusion would be, thus I will eat. And notice that first off, that's a valid argument in the sense that if I assume the first premises are true, the first two are true, then the conclusion would have to be true. If it's true that when I get hungry, I will eat, if it's true that if one thing happens, then the other thing happens, and then that first thing happens, it's got to be true that the second thing happens. Okay, so that's a valid argument. Now notice I could add some variables here to turn it into a symbolic logical form. So I could, let's just say, choose H for hungry, and I could choose anything else, but I'm just choosing H because it seems the most obvious. It's really arbitrary what variables you choose. So now I have first premise, H, and then remember the arrow is the symbol that stands for a if-then statement, a conditional statement. So H arrow, and I'm going to use E for eat. So H for hungry and E for eat. H arrow E. And then the second premise would just be H, because I'm using the same idea, I'm hungry again. And that's all I need there. And then remember the symbol for a conclusion is those little three dots, just means therefore or thus. And then I'd have E. And now, and this is the essence of symbolic logic, it's kind of even easier to see why this is a valid argument. Because here we're using natural language and you kind of have to think about it a little bit. Well, if I'm hungry and I eat, well then I am hungry, so I will eat. It's obvious in a sense, but it's even more obvious with symbolic logic because you can kind of almost see that the H's sort of cancel themselves out. It's like, well, if H then E, and H happened, then E has to happen too, right? It has to, absolutely must happen. So notice that's different than inductive reasoning, which says that the conclusion is probable, right? This conclusion isn't probable given the premises. This conclusion is certain. That's why it's a valid deductive argument. So anyways, maybe I'll just stop with that form and just know that all the rest of the argument forms, again, all the 9 on here, are valid. They're valid. So we could substitute natural language, as I do in the reader itself, to show how they're valid. Right? So anyways, that's the first step in understanding proofs, is understanding validity. So let me do some very simple proofs. So again, you're proving that the conclusion given to you in the proof is valid. That's the whole thing you're doing. So I'm going to start with, just to kind of simplify things, I'm going to start with just a few rules. So right now, take a look at page 72 of your reader if you're watching this video, and forget about the other rules except for modus ponens, modus tollens, disjunctive argument, and the chain argument. All right, so everyone who's watching the video, make sure you're doing that. Look at your page 72. You're looking at modus ponens in the upper left, modus tollens right next to that, chain argument right next to that, and then this disjunctive argument right next to that. Forget about the last 5. We're just going to look at those 4. Okay, so I'm going to write a proof up here, and then I'll show you how I would solve it. So the first premise is E arrow D. The second premise is not D. And again, just keep in mind, we could substitute actual words. We could say, if I eat, then I'll drive. I didn't drive, right? We could do that. We're not doing that, though, because we're focusing just on the validity itself, just on the form of the argument. Remember, validity is about the form. We're sort of forgetting about the soundness or the content or the truth for now. And that can be a major source of confusion with validity, is that there's a confusion between the form of the language and how the arguments fit together and the content of those arguments. And so again, let me be clear, validity deals with the form, and that's what we're dealing with now. So we could substitute in variables here, but we're not going to, because we're just trying to see how the actual form of the argument works and fits together. Okay, so the second premise is not D. The third is not E, arrow C. And then the conclusion is C. Okay, so this is what you're going to be faced with when you're on the assessment. You're going to see something like this, and it will be multiple choice, so there will be certain matches that you have to make, but if you solve the proof that's given, you'll be able to make those matches much better on the assessment. So you're going to want to be able to solve proofs like this for the assessment. So the first thing I'm going to do is I'm going to put a 4 here, because that's my goal. My goal is to get this C, which is the conclusion, alone on a line down here using the rules that I gave you, which is, in this case, these 4. Okay, normally it'll be the 9, but I'm just simplifying it so you guys can follow along using just these 4 rules. So let me say that again. I'm going to try to get C, the conclusion here, on a line down here using these 4 rules. And one of the first things you're going to want to do is just say, hey, well, I see a C right there. Why can't I just take it out? And that's your first mistake, because you can't just take things out of the premises, the lines, without justifying them with one of the rules. That's the deduction process, is that if we assume certain things are true, we're only allowed to use certain operations to get the thing we want. So anyways, I'm trying to get this C. That's the prize. Right? That's the goal. So one of the first things I look at is I say, all right, there is a C here, and I can't get it yet. But if I had a not E, if I had a negative E, I could do modus ponens to get it. Remember, modus ponens is the P arrow Q, P therefore Q. And let me just show you, if I had a not E, right, so look at your modus ponens form. If I had a not E, I could have the same form, and I could get a C. Do you see that, how the negative E would cancel out? If I had a negative E, somewhere on a line here, I could do modus ponens, and that would allow me to put C on the line, right? So right away, I'm working backwards, trying to figure out how can I get to that C, and that's the first thing you should do in a proof. Okay, so since I don't have a negative E yet, and I know if I had one, I could get the C, I look up and I say, well, what else do I have? I have an E here, and it's not negative, but on the other hand, I have a negative D, don't I? And I know that modus tollens allows me to say, well, if I have a conditional statement and I have a negation of the consequent, or the second term, if I negate the second term, then I can negate the first term. So what does that mean? That means if I have a not D, it'll give me a not E, won't it? So what do? So all of this, and one of the tricky parts is all of this might kind of make sense in your head, but showing your work and showing how it kind of works out on the lines can be difficult. So let me show you how you do that. So right away, I'm going to do modus tollens on these 2 lines. And so what I do is I put the negative E here, because again, if E then D and not D, then not E, right? And again, look at your page 72. look at the modus tollens form so you can see why that fits the same pattern. Now to show my work, I would say lines 1 and 2, because these are the two lines I used to get it. So lines 1 and 2, and again, just like in, I think it's 3.5 in the homework that has the proofs, or 3.8, sorry, I can't remember the exercise, but whichever one has the proofs, has the line numbers. So I'm using 1 and 2, because I took these two, and then I'm going to show that I used modus tollens MT, all right? So let me just pull that out so you can see what happened there. So I pulled these two out. I have E arrow D, and I have the negative D, and from that, I was able to conclude negative E, right? But the negative E, I put here. So you guys see that? There's two lines, E arrow D, not D, and the conclusion I took from those two, I put on the fourth line, right? So whatever you get from these 9 argument forms, the conclusion you draw, that's what you're going to put on the line. And you're using any other lines up here as premises to let you draw that conclusion. Okay, so you don't have to pull it out this way. I'm just doing that to kind of show you how it works. And let me just show you one more time how this fits the modus tollens form, right? The P arrow Q, and again, look at page 72, not Q, therefore not P. Okay, do you see that? P arrow Q, not Q, therefore not P. Same thing. E arrow D, not D, therefore not E. Same form, right? That's why I can use modus tollens here. And it allows me to take the conclusion of the argument and put it on the next line. Okay, so that would be my first step. And recall that I said before, if I had a not E, I could do modus ponens here, couldn't I? I could do modus ponens, and that would get me to the C that I need. So now I can do that, because I do have the not E, and so I can put C on line 5. And what did I use to get that? Let me erase this real quick, and I'll show you how that happened. This time, and by the way, as you add new premises, you can now use them. You can use them. So sometimes that's a source of confusion, is students think, well, I can only use the first that were given to me. No, as you add more, as long as you added them logically using the rules, then you can use them in your proof. So anyways, now I'm going to pull out lines 3 and 4, just like I showed you before. And it's going to give me, again, notice that there's nothing magical here. I'm pulling this out directly from line 3. It's the same thing. And I'm pulling this not E out directly from line 4. Same thing. And that allows me to cancel these out with modus ponens and to say that I have a C here. And the C gets put on line 5. Are you guys seeing that? How the premises of each part of the argument that you're using to justify the next line, that you take the conclusion from those premises, from that argument form, and you put it on the line that you're using. Okay, so in this case, I would put lines 3, 4, and this time it's MP for modus ponens, all right? And now, how do you know you're done? That's another question people have, is how do you know you're finished? Well, because I got the C. There's the C, I'm done. I don't have to do anything else. That's what you have to do. You have to get the C, like I said at the beginning, on this final line, and you have to show how you got there using the argument forms. Okay, now this is a proof. The proof is complete. You've proven, your whole goal was to prove that C is the conclusion, and you've proven that the argument is valid, and you've proven that the argument is valid by finding the C here using the other argument forms. Okay, so let me do another one. Sorry, I erased those. I'll keep doing just these 4 for one more. Okay, so I'll do one more with just these 4 argument forms. So here are your premises. JVK, not J, K arrow L, conclusion L. Okay, so everyone see that? J, V, K, J or K, not J, K arrow L, therefore L. Now what's the first thing you're gonna do if you saw this on the assessment, what's the first thing you would do if you saw this proof? You'd write it out on your notes, first of all, and then you'd write line 4 because it comes after 3. There's nothing magical. You're writing the next line, and that's where you're going to start. And now you're going to ask yourself, how the hell can I get L? How can I get the L? Because that's the conclusion. So don't get overwhelmed, just look at the conclusion and then start looking at the proof and start seeing what you can do. And I've limited your options to these 4 rules. So right away I'm thinking, well, I see a J and a K, I see an OR statement. I'm probably going to be doing some sort of disjunctive argument because there's an OR and the DA has an OR in it. Right? Look at page 72, you'll see that the disjunctive argument has an OR. And maybe I'm going to be doing some sort of modus ponens or modus tollens because I have the arrow here. Right? So sometimes you can narrow your options of what you can do just by looking at what's in the proof. But since I know I need the L, I'm thinking, well, if I had a K, I could do modus ponens, couldn't I? P arrow Q, P therefore Q, right? So if I have K arrow L and I had a K, then I could get L. Okay, so again, don't get confused with the letters. As long as they match the form, just because the letters are different, it's still the same argument. So, but before I get to the L, I can't just take it out. I know I'm going to need a K. I see that there's a K in line 1. And then I think, well, okay, it's an OR statement, so I can use the disjunctive argument, but how does the disjunctive argument work? Well, basically it says that if you have one or the other, and then you don't have one of them, that leaves you with the other one, right? And in this case, I can see that I have the negative J already given to me. So I know that if I don't have J, this will cancel out the J and I'll be left with a K. Right, so what would I write on the line? Well, I would write first the K. Because I got the K from here, how did I get the K? Because if I don't have J, I'm left with a K. And what did I use to get there? I used lines 1 and 2, disjunctive argument. 1 and 2, DA. Showed my work, I'm good, I'm ready to move on to the next line. Now, because I see that I have the K that I wanted, that shows me that I can get the L. Right? I can get the L. So now, again, I'm going to put a 5 here because that's just what comes next. If I was on line 6, I would put a 6, nothing mysterious there. And now I can easily see this completely fits the modus ponens form, doesn't it? P arrow Q, P, therefore Q. It fits the same form. It's the same idea. And so I could right away, I can say, all right, I can get an L from doing modus ponens with these 2 lines. Again, try to look and see that it matches the form. And the lines I used, nothing mysterious here, because these are the lines that match the form of modus ponens, these are the 2 that I use, 3 and 4 modus ponens. And it leaves me with the L because remember, MP for modus ponens. It leaves me with the L because remember, the conclusion you draw from the lines you're using, that's what you put on the next line. And the conclusion of K arrow L, K therefore L, leaves me with the L right there. Lines 3 and 4 and MP because I use modus ponens. How do I know I'm done? Because I reached the L. I got the L, right? That's how I know. Okay. So I'm going to do just a couple more. I'm going to do one with all the forms that's a little bit longer. So now you're unrestricting, so to speak, your thinking, and you're looking at all the forms together. And I'm going to do one that's a little more intermediate here. Let's see if I can find one here that has a few other rules in it. Okay, here we go. I'll do this one. All right, so again, you're looking at all the rules, so take a look at page 72, and you're now not restricted to those 4, you're looking at all 9, and I'm going to write up the proof, and then I'm going to do it slowly. So it starts out with an F and G in parentheses, or H, and then an H arrow I, and then a not F and G, conclusion IVG. Okay, so there's your proof. What's the first thing you're going to do? You're going to write a 4 on the next line because that's what comes next. And you know you're going to put something here that gradually gets you towards the IVG. Now, one of the first things I'm going to notice is that I need an IVG, and I don't see an IVG anywhere in the proof. So I know I'm probably going to have to add something somewhere. And take a look at the addition rule on page 72. The addition rule allows you to add anything you want. And that seems a little crazy at first, but remember that it's a true statement. If you have an or statement, if I say I'm going to the store or I'm the king of France, if I go to the store, that's still a true statement, right? Because it's only saying one of the two are true. So that means that I can theoretically, if I have a statement that's already true, I can add an or to it and it'll still be true whatever I add. So anyways, the point is that I see that I have an I here, and if I could get this I alone, I could use the addition rule to add a G, and then I'm done. Right? It seems almost like cheating, but the rules allow you to do that, and that's all we're restricted by is the rules. So if I had an I alone, I could use the addition rule to just add a G to it, and then I would have my proof solved. But I don't have an I alone yet, do I? So I'm gonna have to do a few other things first. So first of all, I'm gonna get an H from lines 1 and 3 using the disjunctive argument. And this is another trick of these proofs, is that if you have a term that is within parentheses, even if it's longer, that counts as a single term, right? So even though this is a little bit longer than the typical disjunctive argument, which says P or Q, not Q, therefore P, or not P, therefore Q, even though this is 2 letters, it still counts as one because it's in parentheses. Okay, so that's the first point. So the reason I can get an H here is because I have a not F and G, and if I don't have F and G, then I'm still left with H, aren't I? That's what the disjunctive argument allows me to do. If I don't have one half of the or statement, I have the other half, and I don't have this half. I don't have F and G. Okay, so now I have the H here. I put lines 1 and 3, disjunctive argument, because I used these two, lines 1 and 3, nothing mysterious. These numbers refer literally to the lines here. I used 1 and 3 disjunctive argument to get me to the H. Now I'm already seeing, I can do modus ponens here. I can pull these out and do H arrow I, H, therefore I, can't I? So I see, modus ponens, that gets me an I. And remember before I said if I had an I could do an addition to get to the G. So I'm almost there already. So now I'm going to go 5, the modus ponens here, and again, the conclusion of the argument form you're using goes on the next line. The conclusion of H arrow I and H is I, isn't it? Because the H's cancel out. So I'm left with the I. And what lines did I use? Well, we already see here I pulled out 2 and 4. Those are the lines I used. 2, 4, modus ponens. And then I have an I, what I needed to have in the first place, so I put one more line, and I can just add the G. Again, I know it seems magical, but it's completely allowed within the rules. You can add any term you need to an or statement. So I need the G. Now let me just point this out. Theoretically, I could add a Q if I wanted to. That's allowed within the rules. Why wouldn't I do that? Because what's the point? I don't need a Q. You're adding what you need to help you narrow down deductively the solution to the proof, right? So sometimes that's confusing. You're like, well, if I can add anything, what's the point? The point is you're adding what you need to solve the solution, right? So you don't just add whatever the hell you want. You could, but what you're adding is what's going to help you get to the conclusion, what's going to help you get the G. So that's why I add the G. I could add a Q, I could add an S, I could even add just a huge long statement if I wanted. I don't need to though, because I'm trying to solve for that conclusion. So what do? I add the G, and now I have the conclusion, but I have to show my work. So I used line 5, and I used the addition rule. And notice, here's another source of confusion. Notice that the addition rule only has one premise. It only has one premise. And that's why I'm only putting one line here. So whichever rule you're using, it's going to have to refer to the amount of premises in that argument. So for instance, if I were to write something like this on a disjunctive argument, 1, 2, and 3, that couldn't possibly be right? That's just deductively cannot be true, because the disjunctive argument only has 2 premises. And these line numbers refer to specifically the amount of premises in that rule that you're using. So once again, just to make sure that it's clear, let me erase that. This is 1 and 3. So pay attention to that when you're putting your rules here, the lines you used, they're always going to match the amount of premises in the rule that you used. For instance, if I said something like 4 and 5 for addition, that couldn't be right because there's only one line in the addition rule. Okay, so anyways, that proof is now fully solved. Fully solved, why? Because I got the IVG, which was the conclusion here. Okay, so I'm gonna do one more longer one, and I'm gonna just kind of go through it more quickly. And this is a video, so you can obviously pause and slow things down and rewind if you need to. So let me do one more. Okay, yeah, I'll do this one. Okay, so we have BV, D and E, GVC arrow not B, DVH arrow J, and then G, therefore J. So we want a J. We want a J. So right away I'm going to start by putting my 5 here, and I'm going to look and see that, I see that I can get a J if I had a DVH. Do you see that? Because remember, anything in parentheses can stand for a single term. So if I had a DVH, I could do the modus ponens thing, couldn't I? DVH arrow J, DVH, therefore J. Right? If I go to the store, I'll buy some food. I went to the store, so I'll buy some food, right? Same principle. So if I had the DVH, I could get to the J. I don't have the DVH yet. So now I have to work backwards and think, well, what could get me to a D? Well, if I had a D and E, I could use the simplification rule. And the simplification allows you to take an and statement and just take one down. If I had the D and E by itself, I could use simplification to take the D down, and then I could add an H to it, and then I could do modus ponens. Right? So I'm just kind of showing you my thought process to show you how you kind of think back in terms of what you can do in the proof, how you're going to solve it. Now, sometimes you might not be able to do that. You might just be overwhelmed. And the best thing to do then is just to start doing things that you can do. That the rules allow you to do. So right away, I'm thinking, well, let's just say I didn't know that. Let's just say that I wasn't working backwards and I wasn't really sure how to solve this. I might say, well, right away I can see that if I had GVC, I could get not B, right? Let's say I don't know why that's going to help me solve it, but let's just say I know that if I had GVC, I could get not B, couldn't I? So, and I know that I have G on line 4. And I remember the addition rule, right? And this is a V, so I could easily add a C here, and then I could get negative B. So again, let's just assume I don't know what the hell I'm doing. I don't know where I'm going. I'm just gonna, just for the sake of it, just start trying things. Start trying things that are allowed within the 9 forms, the 9 rules. So I'll say GVC, and I would say line 4, addition. Again, remember addition is a 1-line argument. 1 premise argument, which is why there's only 1 line. So I took line 4 and I added to it, and the conclusion of that argument is GVC. So I put addition to show that I did that. Now, I know that I can do modus ponens with these two. Remember, I can pull these out just like we did before. If GVC, then not B. GVC, therefore, what? Not B. Not B. And how did I get that? 2 and 5. Right? 2 and 5 are how I concluded that not B is the case. Right? So I put 2, 5, modus ponens. 2, 5, modus ponens. Now, things are starting to get clearer to me, because I'm like, well, okay, now that I have a negative B, I know that I can do a disjunctive argument. And let me just back up. Let me just say, I have this negative B, and I don't know what else I can do. And then I'm just looking around, well, where is there a negative B? Okay, there's a negative B here, but this wouldn't allow me to do modus ponens because this has to be the opposite of what's in the consequent or the second term, right? I'm almost thinking maybe I could do modus ponens or tollens with 2 and 6, but I can't quite get there. The form doesn't quite match with 2 and 6. But then I see, well, there's a B in line 1, isn't there? And I know that if you have not one thing and you have an or statement, which is in line 1, then that leaves you the other one. So I might just say, even if I don't know where I'm going, I might just say, okay, well, if I don't have B, then that leaves me with D and E, right? That leaves me with D and E. So I can go, all right, just for the hell of it, I'll say I don't have B, so I do have D and E. Again, never forget that if it's in parentheses, it counts as a single term. So I can pull out these. Let me just show you this one real quick. B, V, D and E. And if I don't have B, I am left with D and E. And that's why I can put this on the line as the conclusion. Again, the conclusion of the form you use goes on the next line. And again, go back to the page 72 and look at the form of disjunctive argument, and you'll see that it matches the same style, the same form as what's going on here. Right, so now I have D and E, and how did I get that? Lines 1 and 6, disjunctive argument. 1 and 6, disjunctive argument. But I'm not there yet, and you might remember me at the beginning talking about, if I had a D on its own, and then I could add and get DVH, and then I could eventually get to J. Let's just say I didn't know that till now. Now it's starting to get clear to me. I'm thinking, oh, okay, I did a few things. Well, if I simplify this, and this is an and statement, so I can use the simplification rule. If I simplify this, I can get a D alone, and then I can add to get the H, and then I can get the J. Right, so sometimes solving a proof is just a process of elimination. You just do what you can do, and then you see what kind of presents itself. And eventually the solution should become clear as you do more rules and do more things that you can do. And by the way, there will be times that you do a rule that doesn't actually have a place in solving the proof. As long as you did it logically and it fits within the rules, it's not going to count against you. What matters is that you ultimately get to the conclusion. So anyways, now I can simplify line 7. And line 7, again, is a one-line argument. It's a one-line form. So I'm only going to put 7 simplification, S-I-M-P. I'm sorry, I meant simplification is a one-line form. It's a one-line rule. And so I just used 7 and I simplified to get D. Now notice that I could also have taken E. This is totally allowable within the rules. And this is what I was saying before. You can do other stuff, but there's really no point in doing certain things if they're not going to help you solve to get the final conclusion. I could do it, no need to do it though. I don't need to do it for this proof, though I could, just to make it clear how it works. So I could have taken the E, I don't need it, I'm going to take the D. And the reason I know I need the D is because I can apply it to line 3, which has the DVH. So now I can go DVH, and I can use the addition rule because remember, addition allows us to add whatever we want. Could I have added a G or a Q or a Z even? Yes, I could have. Did I need to? No, I didn't. That's why I didn't. I could have, but I didn't need it. I needed the H because I see the H here. So I'm adding what I need to help me solve the proof. So DVH, line 8, addition. Everyone see that? DVH, I took it from line 8 and I added the H because I needed it for 3. And now I know what I need to do to get to the end. So I go, okay, line 10, J, and I found my solution, and I used lines 3 and 9 to get there, and I used modus ponens. Now let me just briefly explain that last one. So just to put the icing on the cake here. So DVH, let's just pull this out from lines 3 and line 9. DVH, arrow, J. DVH, therefore J. Conclusion of the argument goes on the next line, which is why it's 10. Now again, notice that this fits the form of P and Q, P, therefore Q. Okay, same format. Don't get confused by the two terms here. It's a single, it counts as a single term if it's in parentheses. Okay, so I use modus ponens to get to the J, lines 3 and 9. Nothing magical from these lines. I took these numbers are here because they match the lines I used to get this rule, to get this J, to use that rule to get to the J. How do I know I'm done? Because I found the J. I found the J. Okay, so I'm going to end there. I hope that was helpful. And that's it. I'll see you in the next video.